I'm Daniel Levine, and this is the Bio Report. Jeremiah Robison's daughter, Sofia, was born with cerebral palsy, a congenital movement disorder. Watching her physicians use body monitors to measure her gait and later apply functional electrical stimulation as physical therapy gave him an idea to combine the two to create a sleeve that could be worn on her leg to improve her ability to walk. Now Cionic, the company he co-founded, is producing its neural sleeves to help people with a variety of mobility impairments better navigate the world. We spoke to Robison, CEO of Cionic, about the neural sleeve, how functional electrical stimulation helps people with movement disorders walk, and how the use of adaptive algorithms continuously optimizes the stimulation it delivers. Jeremiah, thanks for joining us.
Super happy to be here. Thank you for having me.
We're going to talk about mobility impairment, the Cionic neural sleeve, and how the device can help people who are impaired move with more freedom and control. I'd like to start with your daughter, who was diagnosed with cerebral palsy. How and when was she diagnosed?
So she was born in 2009. She was born quite premature, 2 pounds, 4 ounces, and was 30 seconds delayed in breathing. And it's a pretty common set of preconditions for an eventual diagnosis of cerebral palsy. She was not diagnosed until just after her first birthday. And part of it was, she was hitting all of these verbal and cognitive milestones, and her movement was delayed, but it wasn't entirely obvious until, sort of the way she pulled to stand. And it was clear that there was something that was going on with her mobility. And, we met with the neurologist and the specialist, and they're like, yeah, she has cerebral palsy.
And how has the condition affected her mobility?
So, for those who don't know, cerebral palsy is very similar to a traumatic brain injury or a stroke in that it's a one-time brain injury that can be very diverse among the population. For her specific subdiagnosis is spastic diplegia, which means she has a high amount of spasticity in her legs that makes it difficult for her to sequence motor movements. It's almost as if her body is fighting her as she walks. But she does walk independently. She's gone from using a walker to using quad canes to using just orthotics in her shoes. And you would notice if you watched her walk that she had a mobility impairment, but she does all sort of the mainstream activities with other kids her age.
As part of her physical therapy, therapists used what's known as functional electrical stimulation. What is this, and how did it work with your daughter?
Yeah, so when she was going to physical therapy, we are fortunate enough here in the state of California to have California Children's Services, which is a state-run organization that helps children with physical and occupational therapy. And so she's been doing that, pretty much since her diagnosis and continues to this day. And one of the treatment modalities that they use is functional electrical stimulation. And in the clinical setting, it's basically a set of 1 or 2 pairs of electrodes that you place on the muscles in which you want to activate. And then the therapist will basically walk along with my daughter and press buttons when they want a specific muscle to fire. So that's how we were first introduced to functional electrical stimulation. And what it does is it sends a small amount of current into the muscle body and activates it much in the same way as the brain sends a little electrical signal to the muscle to activate it.
How did this whole experience lead to you founding Cionic?
So it was the combination of this experience and also her gait analysis. We took her down to Stanford University, and they put the little tracking balls on the various parts of her body, high-speed camera. The setup took about an hour. They also measured the electrical signal coming to the muscle from her brain. And she walks 10 steps across a force plate and 10 steps back and get a stack of paper, that says, oh, this is how she walks. So we looked at that scenario. I was like, okay, well, that is how she walks in this very controlled environment. We looked at the situation with functional electrical stimulation in the clinic, which required a person following behind her with two buttons. I said, you know what, we can build something that combines what's great about gait analysis, what's great about functional electrical stimulation, into something that she could wear every day and that could adapt to whatever her environment is and provide the sort of continuous analysis and support that would help her be more independent and be more mobile in her daily life.
What is the Cionic neural sleeve?
Great question. So the sleeve is a wearable neural prosthesis, and it is 2 layers of Lycra that have a set of 24 electrodes that are basically embroidered into the sleeve. So when I say sleeve, think you're watching the NBA and you see one of those basketball players with a sleeve on one single leg. That's what our sleeve looks like, and it should feel like and should wear like it should wear comfortably like clothing. And then through those electrodes, we're able to measure the signal that is being sent from the brain to the muscle. So we can see where someone might have spasticity, might have inability to fire a particular muscle. We also have sensors that are also integrated into the sleeve that tell us where the limbs are in space. So we can basically know what signals are being sent by the brain and what the outcome is with the limbs in space. And then we use that same technique of functional electrical stimulation to basically augment the firing patterns of the muscles to help someone have a more normative, less fatiguing gait pattern.
The sleeve marries the sensors to the functional electric stimulation. What's actually being monitored? What type of intelligence is built into the sleeve?
Yes, and this is a really important point, right? One of our core beliefs is that if you can't measure it, you can't impact it, and you can't personalize it to the user's experience. So those 2 different sensors, we use surface EMG to understand the muscle firings, so what the natural process of muscle firings are for the individual, and then we use orientation sensor, so basically understanding where a limb is in space. And then our algorithms take that information and are able to basically understand how the intervention needs to be optimized. And so one of the common symptoms, for example, of multiple sclerosis, post-stroke cerebral palsy, is called foot drop. And so our sensors are able to watch the pattern of gait and then use that information to know exactly when to turn on the stimulation of the tibialis anterior, the muscles that are responsible for lifting the foot. And if someone speeds up or slows down, or they go upstairs or go downstairs, we can actually adapt the pattern as they're walking. So that's how our system is able to support someone throughout their activities of daily living.
The sleeve actually connects to a smartphone. What is a user able to do with the app?
Yes, we really wanted to put a lot of power in the hands of the users and do that in a device that's being worn on body. So all of the algorithms run in the device itself, and the phone connects to the device to basically do setup, customization, select different exercises that they may want to do, display stats of how fast they're walking, how far they've gone. And so you can almost think of the phone as almost like a remote control that is both used for setup and display of information, and then everything runs on the device itself.
The device is battery powered. What's the life of the battery, and does it have weight that the user actually feels?
The device, the control unit, what we call our control unit, is about the size of and weight of a cell phone. So imagine having a cell phone in your pocket, and that piece is charged, and the performance in terms of battery life really depends on usage. The thing that takes the most battery energy is the stimulation, and some people need more stimulation than others. We've designed it to try to give people all day support. So what we see is, you could call it 6 to 12 hours of continuous wear, depending on how much they're walking and how high the stimulation current is that they need to use.
It's interesting because recently did some work on an exoskeleton, and the physicality of that is so remarkable compared to the sleeve, which does look like something an athlete might wear. It runs from just above the ankle to the hip, but it's a material that looks like a knee brace might look. What was the thinking in the design?
Yeah, when we first approached the problem, we sort of had a pretty clear field view of what might be possible from an augmentation standpoint. So we did look at mechanical actuators, we did look at tensioning devices, and we did look at electrical stimulation. What we see, right, and you mentioned this, that an exoskeleton is quite heavy and has pretty low battery life, but it is indispensable for something like a full paraplegic spinal cord injury. And so in the case of someone who has an upper motor neuron condition, a lesion or damage between the motor cortex and the periphery of the spine, they have all the intact musculoskeletal system. It's just a challenge of activating it. So if we could, and so for someone like that, they're unlikely to want to use an exoskeleton. They can move about, usually using a walker or someone else, but giving them 2 hours of exoskeleton supported gait, is really doesn't give them too much. Being able to give them all day support and optimization using their own musculoskeletal system, it gives you two things. One, long usage, which is awesome. But two, because we're activating their own motor system, there is strength that is being developed, there's blood flow that is possibly increasing, and there's potential for motor learning. And one of the things that's really interesting, and we know this firsthand from my daughter's experience with cerebral palsy, is that the neurological system is highly redundant. She had a procedure called a selective dorsal rhizotomy, which you go in and you isolate basically the neurons that are responsible for spasticity, and you sever them, right? And that's sort of scary. You think, well, like if there's only one wire and you cut it, you can't use it. But that we're such a highly redundant system that the body can relearn, can remap. It's almost like going around construction in your, in your navigation system. And so being able to activate these muscles, their own musculoskeletal system, allows for the potential of motor relearning. And we hear a lot from our users that there is carryover. I use the sleeve and I feel like even when I take the sleeve off, I'm able to move better. We have seen some of our people who basically graduate from using the sleeve. And it's going to vary. It's going to vary highly on the condition, and it's going to vary highly on sort of how much damage and how much compensation, how much atrophy in the muscles. But that would really be the holy grail of anybody who's working in the neurotechnology spaces. Can we teach the body? Can we relearn how to move on our own?
And any idea how the device actually helps people relearn how to move in that sense?
I'll give you some anecdotal examples of what we see when we're in trials and we hear this from individuals, right? So someone comes into our office, and as we're doing this assessment, we'll ask them to perform different volitional activities. One of the common ones is like, okay, let's do toe lifts. And then someone who has had, a damage to that pathway, you'll tell them to lift their toe, and they'll be trying to lift their toe, but they won't see any movement. But when we look in with our sensors and we can see that there's a tiny amount of EMG signal that is showing the intent to fire that muscle, and then we can amplify that, right? We can amplify that with stimulation. And so there's a couple of things that happen right there. It's like, one, if someone tells you to lift your toe and you can't lift your toe, you're unlikely to want to do that very often. So you're not going to do the exercise. So that's step one. And two, by having that connection between the brain and the body and being able to amplify it, the sort of mapping starts to say, okay, the brain is saying this, right? The brain is saying, I can see that I have the power to activate this muscle. And it's basically repathing. It's like if you were to learn how to play the piano or the guitar, you have to learn new movements, and that activates new underutilized neural pathways. So, that's an anecdote of what we see in terms of motor learning happening through the assistance of our system.
Is this customized to each user?
So we have a whole telehealth layer built into our platform that allows us, when we're setting up for a user, they will have one of our mobility specialists that are working with them, almost like on a Zoom call, but we can actually see all the signals coming off of the sensors. We're able to help them set up the right stimulation parameters and select from different gait profiles, so algorithmic gait profiles. And if needed, we can even do some amount of customization for the users. Our algorithms themselves do adapt to a number of different gait profiles. But there's always another layer of customization that we can do if necessary.
And does someone actually have to be trained to use the device, or do they just slip it on and start walking?
Yeah, I think of it a little bit like a hands-on instruction manual, right? So the reason that we have this telehealth layer one is to help people become acclimatized and to set expectations. It is using your own musculoskeletal system. So there is an amount of process of just your body becoming acclimatized to stimulation, of building up muscle and blood flow and range of motion. And so it's nice to have that companion be a real person as part of the flow, and like any other device that we use, as we use it more, we can learn to use it better.
I know this is being used by people with a wide range of conditions, including rare diseases like X-linked adrenoleukodystrophy and hereditary spastic paraplegia. Does the FDA regulate this as a device, and is it approved for specific indications?
Yes, it is a Class 2 prescription-only medical device. And so from an FDA perspective, it is cleared for individuals with upper motor neuron conditions. And so that's a broad range of conditions that includes some very rare diseases, anything that impacts the body from the motor cortex down through the bottom of the spinal column. So and why is that the set of conditions that this is indicated for, is because what we're basically doing is bypassing those lesions or that damage to go from the intent directly to the peripheral system. So we activate a muscle, but we activate a muscle at the nerve root junction. And so the peripheral nervous system needs to be intact for us to be able to do that. And so it turns out that it's quite a broad range of conditions where that is the sort of prescribed damage pathway that we can work with.
Are there size or age restrictions on the device?
Currently, we are cleared for adult use. So in the FDA parlance, that's 22 and above. We do have, a limited set of sizes that covers most of that population, and we're continually working on bringing new SKUs to the market to address sizes that we can't accommodate, and we are actively working now on our trials within the adolescent population to basically bring the age limit down to 12 years old, so adolescents in the eyes of the FDA.
Are there physical benefits from using the device, and are there quality of life benefits as well?
Absolutely, yes to both of those. From an indications perspective, we are helping with gait, and as part of that, as helping people to move and helping people to exercise. So there's two indications from the FDA. One is for gait support, and the other is for what's called neuromuscular electrical stimulation. It really means exercises, so stimulation supported exercises. So we have individuals who have significantly gained muscle mass as a part of that. People who have gained range of motion by doing both the walking and the exercises. We've talked a little bit about how we have anecdotal evidence of people who've had some improved motor learning. And those are all measurable physical improvements, gait speed, et cetera. But it is really fascinating to hear the stories of individuals and to realize how much I take for granted of what walking empowers, right? And so some of them seem mundane. I was able to do my shopping again. I was able to play hide and seek with my grandkids. And it really is about this independence and ability to participate in the activities of the community. And one of our users, in fact, I saw her just yesterday. She has this great quote. It says, "When you walk in a walker, you walk alone." And the big gift that she said that we gave her is the ability to walk hand in hand with her husband again. And this, I do think, is the ultimate evidence of how much benefit our system can have for people is in these qualitative patient-reported outcomes of improved quality of life.
How much does the device cost, and is there reimbursement available for it?
This was another area where we really wanted to try and innovate, was on the pricing model. So I've tried different devices with my daughter, and typically in standard medical device fashion, you pay a lot of money up front to try something that may or may not work or may stop working over time. So we shifted the model, and we charge on a monthly basis. So for the first year, it's $260 a month. And then after that, it is $120 a month. And that covers all of the electrodes, warranty if anything should break, and time with our mobility specialists. And you can cancel anytime. So if we were to send something to you, and not everyone responds well to electrical stimulation, and you said, "Oh, I want to cancel," then you wouldn't pay anymore. So we really wanted to make it something that was, priced in a way that is accessible from a cash pay perspective now, while we're working towards broader reimbursement. We have seen people have the device reimbursed by their payers. It is usually on a case-by-case basis. So now we're working on that evidence towards getting more broad-scale reimbursement. And we believe that, we often hear about value-based healthcare. I think it's a bad label for what is a good thing, which is outcomes-based healthcare. Pay only for good outcomes. And so we're already working towards that model and have something that works for us on a cash pay basis now. And we hope will be attractive to payers to reimburse medical devices, much in the way you would reimburse, say, a pharmaceutical.
Well, what's the conversation been like with payers, and what kind of data would they like to see?
It's really early for us. We are only a year in, so the conversations are are quite preliminary. And, the payers won't always tell you what they want to see. So we're building up our case. We're building additional trials on those longitudinal outcomes. And, I'm hopeful that we'll have some progress on that in not the long, timeframes that you typically have with reimbursement, because we have such great advocacy within the community, right? Like it's rare that you have a first year medical device company with thousands of users, but we do. And that is something that is going to help us in those conversations with the payers.
You talked a little about age, but are there other ways you're working to expand who might be able to use this device?
Yeah, one of the things that we really believe strongly in is the fact that bioelectric medicine, neuromodulation is really on the frontier, and it's early days. And what we wanted to do, and honestly, is bigger than any one company to go solve. So we have a research program where researchers can use our devices and have APIs into the various levels of the stack and can run their own trials. And so we've had interest from the trial community in looking at diseases such as Parkinson's or ALS, diseases that are not upper motor neuron, but are impacting other parts of the neuromuscular system and other parts of the body as well. And so that program is just getting off the ground. We have now 3 different researchers researching different conditions that will help us to see what was possible and hopefully bring more of these solutions. And our ethos around that platform is, what can happen if we can get new device-based interventions into the market at software speeds and software costs, right? The average time and dollars that it takes to bring a new device to market is 6 years and $30 million. And then that's just too expensive. And especially when you're thinking about rare diseases where the market might be small, that's so expensive to get a new indication to market. But we've seen as software has been eating the world, that you can get things at software speeds and software costs much faster, much less time. And that's the ambition. Can we use the existing hardware platform that we have, the existing sleeves, but open up new indications just by building new algorithms, just by building new stimulation paradigms? So we're excited about that. It's early days, but that's sort of the big scale ambition for what we're doing at Cionic.
And how's the company financed to date, and how far will existing cash take you?
Well, we started in 2018 and we are venture backed. And I am fortunate to have a number of really fantastic, both Valley insiders and people from the venture landscape to support us, who are believing in what is a long and ambitious journey. But we see that the venture is now more willing to take on regulated spaces, more willing to take on longer term profiles. And so we have a good amount of cash, and I'm hopeful with our current progress that will actually get us to profitability as a company, and that we'll be able to both continue to offer these outcomes and these amazing results for our users, and like you said, expand it to more and more populations with the investors that we have today.
And how's your daughter doing? And does she use one of the sleeves?
Yeah, well, she uses 2 actually. So she's a bilateral user. She uses it on her left and right side. She is doing amazing. What's really cool about having something that is so part of our family experience. My wife runs a nonprofit to help families like ours who have a child with a mobility disability diagnosis. I'm the technology side with our company, and our daughter helps us both. And she's an amazing spokesperson, both for us and both for Cionic and for my wife's nonprofit, and also for herself. And it's really cool to see. We asked her, a few years back, are you willing to speak publicly about what is going on in your life? And that has been such a key for so many different populations, right? You see with Michael J. Fox in the Parkinson's community, now with Selma Blair in the MS community. When people are out there and vocal and willing to share their experience, it helps folks not feel alone. And I'm so proud to be her father and the young lady that she is becoming, and the advocate for people within her disability community.
Jeremiah Robison, CEO and co-founder of Cionic. Jeremiah, thanks so much for your time today.
It was a real pleasure. Thank you so much for having me.
Thanks for listening. The Bio Report is a production of the Levine Media Group. To automatically download this podcast each week, subscribe to our RSS feed or through iTunes or other podcast manager. To join our mailing list, go to levinemediagroup.com. We'd love to hear from you. If you want to drop us a line or are interested in sponsoring this podcast, send an email to danny@levinemediagroup.com. Special thanks to Jonah Levine, who composed our theme music, and the Jonah Levine Collective, which performs it.